Hello everyone, here in this video we are going to discuss one of the most important question of ISRO 2014 that is very tricky, logical and very interesting. See here, the question is what is the output of following C program? The question is very simple. First header file inclusion, then main function, and thereafter we are having one integer variable whose name is shifty. Shifty here is a variable name whose type is integer. Now what we are doing, we are assigning some value to this shifty operator, that is 0570. Now there is one rule that if any integer variable starting with 0, if any integer variable starting with 0, it means that it is a octal number. It means that it is a octal number. And you know octal number range is 0 to 7, right? 0, 1, 2, 3, 4, 5, 6, 7. So we can represent these 8 numbers using 3 bits. How many bits? 3 bits. 3 bits are sufficient to represent all these numbers. So I can represent this 0 as a 0, 0, 0. I can represent this 5 as a 1, 0, 1. I can represent this 7 as a 1, 1, 1. And we can represent this 0 as a 0, 0, 0. Now, we have done up to here. Now, next part is shifty equals to shifty. And this symbol, this two angle symbol on the right side indication indicates that this is right shift operation. This represent right shift operation. Getting it? So right shift means we need to shift 4 bits toward right side. So let me try to do it. What we are having right now, 0, 0, 0, 1, 0, 1, 1, 1, 1, 0, 0, 0. Right shift operation, how much? 4. So I need to perform 4 right shift operation. This 0 will shift to right. This 0 will also shift to right. This 0 should also shift to right. And this 1 will also shift to right. What I did, this is for shift operation, for right shift operation. Now we need to eliminate it. So what is remaining? I need to write into the group of 3 bits. Why? Because I am trying to represent them in a binary equivalent. So to represent any octal number, to its equivalent binary number, we use 3 bits. So 1, 1, 1, 1, 1, 1, and then 0, 1, 0, 0, 1, 0. Getting it? And remaining 2, 0. So we can add as many 0 on the left side. It is not going to effect, it is not going to impact our binary notation. I hope that you are going to get the things very clearly up to here, right? Now what we are doing here, shift, and this indication, this symbol is left shift operation. This symbol is what kind of operation? It is representing left shift operation. So in left shift operation, what we need to do, we need to shift 6 bits toward left side, towards left side. I will shift this 0, I will shift this 0, I will shift this 0. And I also need to shift, as you can see, 3 zeros are already shifted. So it means that I need to add 3. Let me try to do. I can write this complete symbol as a 0, 1, 0, 1, 1, 1. I am not counting these zeros. Why I am not counting? Because this is binary representation. And in binary representation, if we are going to add as many 0 on left side, it is not going to make any sense, right? That is why this complete representation I am writing like that. And I need to do 6 left shift operation. It means that on right side add 6 zeros. If I am going to do this, it means that what I did, I performed 6 left shifts. How we can say? Because doing this kind of things are not going to make any sense, because we can add as many 0 on left side of binary notation. It is not going to make any sense, right? Because number will not change. So to make 6, whatever number of shift operation we want to make in binary notation, that much zeros we are going to add on the right side. So this is the equivalent of this. Means I have performed 6 left operations, 6 left shift operations. After that, the value of 50%, we want to represent it into octal form. So the octal equivalent of this number is 2700. Option 4. Octal representation is like this. Now let me try to give you some more scenarios so that if you are going to have here percent d, let's say suppose if you are having percent d, how to calculate is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 into 2 to the power 10 plus we can eliminate this 0, we can eliminate this 0 because we need to multiply this 0 with 2 to the power 9, which is not having any sense. It will be 0 plus 1 into 2 to the power 8 for this one, plus 1 into 2 to the power 7 for this one, plus 1 into 2 to the power 6 for this. And all this will be like 0 into 2 to the power 5 plus 0 into 2 to the power 4 plus 0 into 2 to the power 3, like that, likewise that. So ultimately this will be 0, this will be 0, this will be 0, this will also be 0. Ultimately it is 1024 plus 256 plus 128 plus 64, right? So ultimately if you are going to add them, and you are going to get like 1472, 1472. It is the it will be the answer. It will be answer. When it will be answer? When percent d will be here. It means that we need answer in decimal form, but we do not need answer in decimal form. We need answer here in octal form. So octal equivalent, octal equivalent, octal equivalent of this notation, octal equivalent of this notation is 2700. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you can count, you can calculate your octal equivalent like 1 into 8 to the power whatever, and 8 into 1 2 to the power. You know that if you can represent any number into the binary decimal, simply you can represent that number into octal also. For octal we are having ranges from 0 to 7. We are having ranges of octal number is 0 to 7, right? So here doing the same kind of steps, you can convert it into the octal, and octal equivalent would be 2700. So option D is the correct answer. I hope you got the doubt clear and you got the answer of this program, right? Thank you so much, guys. For such kind of more questions, do subscribe us and stay tuned with us. Thank you so much.